Highway, bridge, and airport runway joints call for tough sealants that can withstand excessive horizontal and vertical movement, have good weatherability, are easy to install, have a short downtime, and have a long service life. DOWSIL brand silicone pavement sealants do the job. Our sealants can be installed over a wide temperature range. They can cure upon exposure to moisture in the air, forming a permanently flexible, high elongation silicone rubber seal. Unlike organic-based, pre-formed neoprene or hot and cold-poured sealants, silicone sealants don't crack, crumble, dry out, or become brittle. Our sealants are capable of withstanding 100% extension and 50% compression of the original joint width. They have excellent recovery, which makes them ideal for use in joints that experience a high degree of movement. DOWSIL sealants remain flexible and resilient years after installation. Studies have shown that they have a minimum of 10 years of service life, and some are still working after more than 30 years. Their temperature stability means they do not get brittle in the cold or too soft in hot temperatures. Easy to install, the silicone sealants allow traffic to be back up and running quickly. When using any DOWSIL brand silicone joint sealant, make sure that you are following all safety guidelines, including the use of correct personal protective gear. You must also comply with local, regional, and federal safety guidelines. For each DOWSIL sealant, thoroughly review the safety data sheets, or SDS, before using the product. The SDS are available at consumer.dow.com/construction or by contacting the Dow Technical Information Center at 800-248-2481. DOWSIL 902 RCS joint sealant is a rapid cure, self-leveling, two-part silicone rubber sealant. This sealant is primarily used to seal bridge expansion joints that vary from 1 to 3 inches. DOWSIL 902 sealant can be used in new construction or remedial repair. Its rapid cure rate allows faster resealing to minimize traffic disruption. More than 20 years of field performance have demonstrated that DOWSIL 902 RCS sealant is an excellent choice for sealing expansion joints that experience thermal and vertical movements. We'll demonstrate how to use DOWSIL 902 RCS joint sealant as part of the X.J.S expansion joint system. Silicone Specialties Incorporated, or SSI, created and patented X.J.S. Dow is a partner in the system, providing the DOWSIL 902 RCS joint sealant used with SSI's SilSpec 900 polymer nosing system. When combined with aggregate, the SilSpec 900 product forms a semi-flexible, wear and impact-resistant nosing. DOWSIL 902 RCS sealant is used to form the flexible rubber gland for the joint. The X.J.S materials may be placed in joints that vary both in width and depth, with a substrate of steel or concrete, or a combination of both. The X.J.S system offers the answers to problems on strip seals, rubber plank systems, armor joints, and joints with asphalt or concrete overlays. Even joints that are too wide and need to be closed up, or small joints that need to be widened, can all be repaired to give a functional, watertight structure. The easy installation of the system means that crews can begin work after morning rush hour and have a bridge repaired and back in service before the evening traffic starts. The X.J.S system is installed in a series of simple steps. The system's excellent performance depends on several factors in the field. To get the maximum performance, the system must be properly installed in joints that are properly designed and prepared. First is the removal of the old joint system. It's critical that the concrete substrate is structurally sound. If working cracks are encountered, they must be treated as a joint and formed and sealed. Using nothing larger than a 30-pound chipping hammer, chip any loose or unsound material down to structurally sound concrete. Next, abrasive blast the substrate to remove all contaminants. With a steel substrate, check for soundness. Then abrasive blast until you have reached white metal. After abrasive blasting, the joint and surrounding areas should be blown clean of all dust using compressed air of at least 90 psi. Air compressors must be equipped with traps capable of removing moisture and oil from the compressed air line. After cleaning, the joint is ready for forming. we're going to simulate some different joint configurations you're likely to encounter in the field. Forming should be done using extruded polystyrene, such as styrofoam extruded polystyrene insulation from Dow. Expanded polystyrene, or what is commonly called beadboard, is not chemical resistant or strong enough to work properly and should not be used. Tools for forming are simple and inexpensive. For cutting the foam, use a long blade razor knife and straight edge. Or, for thicker pieces, a skill saw will work well. You'll also need a tape measure, duct tape, a margin trowel, and open-celled polyurethane such as tundra foam. Many times, joints have closed to the point that it is impossible to provide a functional joint without resizing the opening. With this system, the styrofoam forms are made to the desired dimensions and placed over the existing joint. The forms are held in place by styrofoam cleats, which are removed as the nosing is placed along the forms. Remember to make the cleats higher than the recess so they cannot be covered up and lost in the nosing. Sometimes, it's the opposite situation, and the joint is too wide and needs to be closed. By placing regular, tight backer rod, not the soft type, next to the styrofoam form, the SIL-SPEC 900 nosing can be placed in the blockout and down the face of the joint. It is important that the nosing be placed a minimum of 5 inches along the vertical face to give maximum support. Remember, any adjustments to the existing joint width should be agreed to by the engineer, contractor, and manufacturer prior to commencing work. Many joints are in poor condition, and once demolition has started, large pieces of concrete must be removed in order to reach sound material. The result is a very rough, jagged blockout. This system provides a simple solution. Place a styrofoam form deep enough into the joint to reach below the damaged areas. Using open-cell urethane foam, such as tundra foam, plug any opening between the form and the concrete. It is important that the urethane foam be placed as far down the joint face as possible. Care should be taken not to allow the urethane foam to create any voids, which would reduce the amount of support given to the nosing. To avoid a stress point in the nosing, it is very important that any significant changes in the width of the nosing have a 45-degree transition. If this is impractical, place 2 lengths of number 4 preformed reinforcing bar across the transition. The bar should extend 1 foot on each side of the transition. For joints that experience severe movement during the cure cycle, a special forming technique is used. 2 pieces of tundra foam are sandwiched between the styrofoam forms, allowing the joint to move horizontally as well as vertically without disturbing the nosing during cure. Now we install the SIL-SPEC 900 polymer nosing. It is available in several package sizes, which contain components A and B, as well as the blended aggregate. All chemical reactions, including the curing of SIL-SPEC 900 nosing, are affected by temperature. Consequently, applications in either very hot or cold conditions require somewhat different storage and placement techniques. Please contact SSI for guidelines. Remember to read and follow safety data sheets and handling precautions. And use proper protective equipment. If solvents are used for equipment cleanup, be sure to follow your health and fire precautions exactly. To clean the SIL-SPEC 900 product off the skin, a waterless hand cleaner works well. When large kits of SIL-SPEC 900 nosing are used, mix the liquid components prior to blending with the aggregate. Do not attempt to hand mix large kits. Use a drum mixer with an internal scraper or a small paddle-type mortar mixer for blending the liquids and aggregate. Regular cement mixers do not work well. In either case, remove about 1 gallon of aggregate from the first kit that is blended to compensate for the liquid required to wet out the mixer. For demonstration, we're using a small kit and a heavy-duty 1/2-inch drill with a heavy mixing paddle, 2 5-gallon pails, measuring cups, and miscellaneous hand tools. If you're planning to blend less than full cans, the A and B components should be thoroughly pre-mixed before measuring these liquids. If you're using full containers, pre-mixing of the components is not required. To clean the mixing paddle in between uses, we use aggregate soaked with toluene. Remember, this solvent is flammable, and precautions should be taken to ensure safety. The freshly stirred material should be carefully measured. Equal portions by volume are then blended and thoroughly mixed. Now we blend the polymer nosing. When emptying the cans, use a rubber spatula to wipe out the cans. As much as 10% of the liquid components can remain in the cans if they are not thoroughly wiped clean. This would negatively affect the final mix. Combine the A and B liquids and mix. Be sure to work along the sides and bottom of the container so all of the materials are blended. While continuing to stir, slowly add the blended aggregate to the liquid. It is important to move the mixer from the top to the bottom during the mixing process to lift the liquid-rich material on the bottom to the top of the bucket. Keep mixing for at least 3 minutes. Use a watch. Don't guess. Dump the mixed material into a second bucket and continue mixing for another 3 minutes. This additional step will ensure that the liquid is thoroughly and evenly dispersed throughout the aggregate. Improper mixing will result in wet and dry spots in the mix and cause high porosity in the cured nosing. Now place the polymer-based mortar into the joint. Use a margin trowel to force the material against the styrofoam form and back edge of the joint. Using a steel trowel turned lengthwise in the joint, push hard on the mortar to ensure good compaction. When the compaction is correct, liquid will begin to appear on the surface, and the surface will have a wet, shiny appearance. If the nosing is dry and granular looking, then compaction is not complete. Improperly compacted materials will be weak and porous. If the joint is to be repaired in stages, finish the end of each section so the mortar is at a 45-degree angle. This will increase the bond surface and the structural integrity when the fresh mortar is placed against the previously cured material. There is always pressure to put traffic on the joint as soon as possible. However, putting traffic on material with insufficient cure time can destroy the integrity of the joint. To ensure that the cure is adequate throughout the mass, and particularly at the bond line at the bottom, we suggest that a small section of the form be cut out so the bond line can be examined. Simply reach to the bottom of the nosing to make sure that the liquid is completely cured and hard. Check for soft spots in the nosing mass. A few extra minutes of cure time are certainly a good investment compared to destroying the integrity of the joint. Once the material is completely cured, you are ready to remove the form. Either a small chainsaw or a sawzall makes removal fast and easy. With the form removed, use an angle grinder to grind a bevel of approximately 1/4 inch at the edge of the joint. This easy step increases resistance to chipping. After beveling, the joint needs to be abrasive blasted to remove all traces of the foam material. Now we're ready to start applying the rest of the X.J.S system, the DOWSIL 902 RCS sealant. Priming and sealing must happen on the same day. The priming operation should not be more than 1 hour ahead of the sealing operation at any given time. Before applying the primer, the joint and surrounding areas should be blown clean of all dust using compressed air of at least 90 psi. Air compressors must be equipped with traps capable of removing moisture and oil from the compressed air line. Apply the primer following the manufacturer's instructions. Allow the primer to dry completely. Check the joint face for dryness prior to installing the backer rod. Take care to place the backer rod at the depth recommended in the manufacturer's literature. Use a depth gauge to ensure proper installation of the rod. For less switchover, use the larger DOWSIL 902 RCS sealant kits and an air-powered 2-part pump, or use the convenient sausage packs with air-powered sausage guns. Connect the A and B components to the pump or to the gun. Extrude a small amount of liquid into a cup to make sure that the liquids are dispensing equally. Attach a mixer. Extrude a small amount of material and make sure that the liquids are being thoroughly blended. Look for uniform color and no streaking. Now you can simply pump the blended sealant into the prepared joint. Check the depth of the sealant over the backer rod frequently. Also, make sure that the recess of the sealant to the top of the joint is proper. If the sealant is too high and comes in contact with tires, the life of the sealant will be dramatically reduced. The X.J.S system is easy to repair. If a small section of a joint is damaged, these easy steps will quickly repair the joint to like-new condition. Remove the damaged material. Abrasive blast the area that will receive the new nosing. Place the styrofoam form. Prime. Then reinstall the SilSpec 900 polymer nosing. After this cures, remove the styrofoam form. Then abrasive blast to remove any excess styrofoam material. Cut the old sealant to expose fresh silicone surfaces. Prime the new joint face. Install new backer rod and replace the damaged silicone. There you have it. Good as new. A waterproof joint ready to go back into service.